Hello everyone. Today we are going to discuss how to draw the graph of y equal to f1 of x plus f2 of x and also y equal to f1 of x multiplied by f2 of x. Nothing but how to draw the graph of addition of two different types of functions and product of two different types of functions. Let us discuss today. Suppose that there is a function y. It is combination of two different types of functions f1 and f2, and another one product of two different types of functions f1 and f2. First one f1 of x plus f2 of x, and second one f1 of x multiplied by f2 of x. To draw the graph of any function, first you have to decide the domain of the function, in which interval that is well defined, that you have to decide first. And here y is clearly, that is the combination of f1 as well as f2, so that to decide the domain of the function, first you have to decide the domain of both f1 as well as f2, so that first you have to decide the domain of f1, and after that you have to decide domain of f2. This is step 1. Step 2. Next, in the third step, you have to write domain of f1 intersection domain of f2, that is equal to, that is domain of given y, whether it is f1 plus f2 or f1 into f2, the common domain is domain of y. You have to decide the common domain, and after that you have to draw the graph. Let us discuss different types of graphs which are of the form f1 of x plus f2 of x and f1 of x into f2 of x. First, let us select a function y. I am going to write a function y. Suppose this is combination of step x and fractional part of x. The combination of two different types of functions. First one is greatest integer function and second function is fractional part of a function. We know that domain of first function, that is domain of greatest integer function, it is defined for all real values of x. Next you have to write domain of second function, fractional part function, also defined for all real values of x. And now to draw this graph, you have to decide the common domain. Both belongs to R, so that common values, common domain clearly set of all real values. So on real line, the graph defined for each and every real value of x, remember. Yes. You know that the value of x, suppose if you write 0, then step value also 0, fractional part also 0. When you put x value 0.5, in which greatest integer of 0.5 nothing but left side integer, left side greatest integer, you have to write 0. Next fractional part of 0.5 nothing but the same 0.5 we get. If you put input 1, what is greatest integer of 1? For integer itself, so 1, and fractional part 1, that is 0. Next, if you put input 1.5, in which fractional part is 0.5 and greatest integer left of 1.5, that is again 1. So now the combination of these two, combination of these two is y, so that y equal to step x plus fractional part of x gives the results 0 plus 0, 0, 0 plus 0 0.5, 0 0.5, 1 plus 0, 1, 1 plus 0 0.5, 1.5. And observe input as well as output. If the input is 0, then output the same 0. If input 0.5, output same 0.5. If input 1, 1.5, output also the same 1 and 1.5. So here the values of x as well as y, input and output both are same, so that x equal to y or y equal to x. So the combination of given two functions is clearly indicates the graph of y equal to x. Also you know that fractional part of x defined by x minus step x. Transfer greatest integer into the left side, step x plus fractional part of x, that gives the result x itself. So it is enough to draw the graph of y equal to x. Very simple. Y equal to x graph that indicates a straight line which is passing through origin and that makes an angle 45 degrees with the positive direction of x axis in the counterclockwise sense. This is how to draw the graph of combination of two different types. Let us move to another example. Suppose that there is a graph y equal to x plus sin x. You know that to draw the graph of combination of two functions, first you have to decide its domain. Due to combination of two functions, first you have to write the domain of first function and then second function. After that, the common domain of both first and second, that is the domain of given y. You know that y equal to x, straight line passing through origin defined for all x belongs to R. And next, suppose this is y1 and this is y2. y1 equal to x, straight line defined for all x belongs to R. y2 sin x, sin x also defined for all x belongs to R, and the common domain, their intersection, that is the domain of y, also R. Therefore, we decided that domain of the function y clearly set of all real values. On real line, now I am going to draw the graph of y equal to x plus sin x. Input x to the first one y1 equal to x, to the second one if you give y2 sin x, and then go for combination of these two. Y is combination of x and sin x. Suppose if you write 0, pi by 2, pi, 3 pi by 2 and 2 pi, what happens? Observe. y1 equal to x, the same values here, pi, 3 pi by 2, 2 pi. Next, sin 0, 0, sin 90, 1, sin pi 0, sin 3 pi by 2 minus 1, sin 2 pi 0. Combination of these two. 0 plus 0, 0. Next, pi by 2 plus 1. After that, pi plus 0 become pi. Next, 3 pi by 2 minus 1 and then 2 pi. On Cartesian coordinate system, now let us see the graph. Clearly, if you give input 0, the output is also 0. Origin is first point. If you give pi by 2 input, for which additionally you have 1 unit, pi by 2 plus 1. So, if the value of x is pi by 2, pi by 2 plus 1, 1 unit extra. This is actually pi by 2, 1 unit extra, pi by 2. Next, for pi, the same pi. So, the same length along x and the same length along y here, pi, pi. Next 3 pi by 2. For 3 pi by 2, you have to reduce 1 unit. 3 pi by 2, 3 pi by 2, let's reduce 1 unit to this here. Next here, here and here. Now if you put x value 2 pi, output also 2 pi. So 2 pi and 2 pi here. Joining all these, we get the graph in this way. In the same way, for negative values of x, this is the graph. And also one thing you have to observe here, y equal to x plus sin x you have. Sin x value always lies between minus 1 plus 1. When you add x, it is x plus 1 and it is x minus 1. So the graph of y equal to x plus sin x in between two straight lines, y equal to x minus 1, y equal to x plus 1. Clearly the graph of x plus sin x, if you observe, that is lies between x minus 1, x plus 1. Yes, here it is one straight line and here it is of another straight line. This is y equal to x minus 1 and this is y equal to x plus 1. Yes, this is the graph of y equal to x plus sin x. Let us move to the another graph. Suppose that if you have y equal to e power x plus e power minus x, let us see how to draw the graph of this. First you have to decide the domain, right? What is domain of e power x? E power x is defined for all real values. E minus x also defined for all real values of x and common domain. So intersection of these two become again set of all real values, so that domain of the function y clearly set of all real values. You know that suppose x equal to 0. First e power x graph I am going to draw. First e power x graph. When you put 0, e power 0 nothing but 1. When you put 1, it is e power 1, nothing but e here, approximately 2.7. Next, and this is the graph. Okay, this is e power x graph, rapid growth function. Next, e power minus x graph. Graph of e power minus x. You will get in this way. This is e power minus x and this is clearly e power x. Now the combination of these two, that is y. Particularly at x equal to 0, what happens? Observe, at x equal to 0, both having same height 1 unit. E power x value 1, e power minus x value also 1, and their combination become 2. Therefore here it is 2. Next, suppose x equal to 1, what happens? E power 1, 1 by e. So it is clearly more than e. E plus 1 by e, that is more than e. Next, if you put x value minus 1, first term become 1 by e. Due to minus 1, it is 1 by e. Next, e power minus of minus 1, that become e. So these two are same and clearly more than e. Both are same and more than e. Here at 1, it is more than e here. At minus 1 also it is more than e. The same quantity you will get. So for positive values of x and negative values of x, the output is same, and joining all these points, we get the graph this way. This is the graph of combination of 2, y equal to e power x plus e power minus x. This one is the graph. This shaded portion indicates combination of these two. Next, move to the next graph, that is of the form product of two functions. Suppose that there is another function y, it is product of two different functions y equal to x into sin x. First you have to decide domain, whether it is addition, subtraction or multiplication or division, whatever it is. First you have to decide the domain of the function that depends upon the common domain of given functions. You know that x is defined for all real values of x, sin x defined for all x belongs to R, for all real values of x, that is both defined, and their intersection, that is set of all real values, that is domain of y. So now you have to draw the graph of y for all real values of x. Also one thing you have to remember, sin x value always lies between -1 plus 1. When you multiply with sin x, when you multiply sin x with x, x sin x lies between -x and x, remember. So y equal to x, y equal to -x minima, y equal to x maxima to this, to the given function x sin x. Yes, let us see the graph. X sin x, whose domain is R, set of all real values from -infinite to infinite, and it is decided that the graph exists between the two graphs y equal to x and y equal to -x. You know that this is the graph of y equal to x and this is the graph of y equal to -x. Y equal to x, y equal to -x. In between them, the graph of x into sin x exists, and suppose if you write x value 0, what happens? X sin x, 0 into sin 0 becomes 0. Therefore, origin is 1 point. Next, if you put x value pi by 2, y, pi by 2 into sin pi by 2, sin pi by 2 value 1, 1 into pi by 2, pi by 2. If you give input pi, y equal to pi sin pi, that becomes 0. Next, if you write the value of x as minus pi by 2, therefore y become minus pi by 2, sin of minus pi by 2, that is minus 1, become pi by 2. Next, if you put x value minus pi, what happens? Minus pi multiplied by sin of minus pi, that is 0, right? 0 comma 0, 1 point, 0 0 1 point. Next, pi by 2, pi by 2. At pi by 2, it is pi by 2, nothing but lying on y equal to x. Next, for minus pi by 2 also it is pi by 2. For minus pi by 2 also it is pi by 2. Next, if you put x value pi, it is 0 again. Here, suppose it is pi, 0, pi by 2, the same. Here it is of minus pi by 2 and here it is of pi. For minus pi again it is 0. Joining these points, we get the graph in this way. Yes, this is the graph of y equal to x into sin x. So, you have to draw the graph of both f1 plus f2 and f1 into f2 on common domain of f1 and f2, remember. Let us move to the next. Suppose that the question is, if you have y equal to minimum of sin x comma cos x, this is the question. How to draw the graph of y equal to minimum of two functions and maximum of two functions, let us discuss now. Here in this case, first both the graph of sin x and cos x on the same Cartesian coordinate system, first draw both the graphs and then decide minimum part of sin x and cos x, that gives the result of y equal to minimum of sin x and cos x. What I am saying, both the graph of sin x and cos x on Cartesian coordinate system, at a glance both in one system you have to draw first, and after that you have to decide minimum portion. You know the graph of sin x in the interval 0 to pi, next pi to 2 pi, and it continues up to minus pi to minus 2 pi. This white colored graph indicates the graph of y equal to sin x. Next draw the graph of cos x. Maximum 1, minimum minus 1. Cosine graph I am going to draw. This one is the graph of cos x. This is y equal to cos x. But here required graph is minimum of sin x comma cos x. Now you have to choose the minimum quantity from both sin x and cos x. Particularly at origin, the value of cos x 1 and the value of sin x 0, in which minimum is 0, right? See here, this is the minimum portion of these two graphs, and here observe green colored is minimum compared to white colored. So this is the minimum portion of both sin and cos. Here both are same. Next, minimum of sin cos, nothing but here white colored is minima. Next, and here in this interval green colored is minima. So this shaded portion indicates minimum of both sin x and cos x. This is the graph. This is the portion that is minimum of given two trigonometric terms. So this is the graph of y equal to minimum of sin x comma cos x. Okay. To get the maximum of sin x cos x, you have to select the maximum portion. The graph which is defined, that should be maximum compared to these two. Let us discuss next example. Suppose that the question y equal to maximum of modulus x minus 1 comma modulus x comma modulus x plus 1. Suppose this is the question. Here required function, that should be maximum of three functions given inside mod x plus 1, modulus x minus 1. Let us draw the graph of mod x minus 1, mod x plus 1 at a glance, and then decide the maximum part. Out of these three, only the maximum part you have to choose. Yes. See the graphs in one system. X axis, y-axis. First draw the graph of y equal to mod x. You know that mod x graph, that is V-shaped diagram, it has sharp edge at x equal to 0. This is y equal to mod x. Next, the graph of modulus x minus 1. You know that mod x graph sharp edge at 0, mod x minus 1 graph sharp edge V-shaped graph, but sharp edge exists at x equal to 1, and for modulus x plus 1 also V-shaped diagram, but sharp edge exists at x equal to minus 1. When you put x equal to minus 1, it becomes 0, right? Mod x value minimum quantity for last one at x equal to minus 1, and for which at x equal to 1, and for which at x equal to 0. So V shape minimum portion sharp edge at x equal to minus 1 here, and for which sharp edge plus 1. So first I am going to draw mod x minus 1 graph. Mod x minus 1 sharp edge at 1. Sharp same V shape graph, but sharp edge at 1. One sharp edge 0. Next, graph of mod x plus 1. Mod x plus 1 that has sharp edge at minus 1. This one is the graph of y equal to mod x plus 1, sharp edge at minus 1, and this is y equal to mod x minus 1. Here the requirement is maximum of these three. Maximum of these three, nothing but maximum of all the three. See here, this is only the maximum part, remaining two below this. So this shaded portion indicates maximum of given 3. And next, in this region this one is greater, and next in this region this one is greater. And this is the graph. And also you can rewrite the given function as y equal to, for all positive values of x, it indicates the graph of y equal to mod x plus 1. Mod x plus 1 is maxima. Next, for all negative values of x, this side, this is the graph, nothing but modulus of x minus 1. So you can also rewrite the given question in this way, and clearly here the maximum portion of given 3 modulus functions is clearly shaded. This is the part of the graph of y equal to maximum of given 3 modulus functions. Let us discuss another example based on this. Suppose the question is y equal to minimum of mod x comma 2 minus mod x. This is the question. Here first we have to draw the graph of y equal to mod x, that is V-shaped graph, sharp edge at 0. This is y equal to mod x. Next, second one, graph of 2 minus mod x. First mod x, next transformation minus mod x, and for which addition 2. You know that the graphical transformation, mod x is nothing but V-shaped graph, minus mod x nothing but reverse V. Next, for modulus x, for minus sign as well as plus 2 is there. Just for minus mod x you have to add 2 units. When you add 2 units, it goes like this. So this is the graph. So sharp edge reverse V, sharp edge at 2, remember. So reverse and sharp edge at 2. This is the graph, and here the requirement is minimum of these two. Minimum of these two. This is the portion. This is only the minimum portion. No other graph less than this. Up to here it is minima. Next this one is having minima. No other graph less than this. And here this is the minima. Next, compared to these two, this one has minima. So this is the graph of y equal to minimum of mod x comma 2 minus mod x. So this is the way of calculating maximum minimum of given two functions, graph of minimum and maximum of two functions. So these are helpful, interlinked with the topics continuity, again differentiability and applications, maximum minimum concepts, as well as in definite integrals, particularly in areas. These graphs are helpful. See, in this figure it has three sharp edges, so that it is not differentiable at 3 points. Okay. Next, and this is the graph. I can say that it is continuous everywhere. Why? Because you have the graph without gap, without breaks and jumps, right? So that you can decide continuity and differentiability. Also you can find the areas. So the students, those who are aspirants of JEE, they must learn how to draw the graphs and graphical transformations, as well as combination of functions, product of functions, and minima maxima of given two or more functions. You have to concentrate on these topics, then only you will get the solution within a short span. Thank you.